Hello and welcome to my video 4.3, Other Forms for Linear Equations. So before, in the last video, we looked at y equals mx plus b. And we talked about this being the slope, or the steepness of the graph, and this being the y-intercept. Okay, so we need to have that previous knowledge, so if you don't remember this, please rewatch the last video, 4.2. But with that in mind, once we have it in the form y equals mx plus b, then we can easily do our graphing based off the last video. So what we need to do when we see something in a different configuration, like this one, is we need to rearrange it. Now, I've given you a really simple, well, not so simple, a little bit of a complicated formula here. This is a formula where you can literally, if you've got C for 4, you can plug it in for C over here. If you've got 2 for D, you can plug that in for D there and there. And if you've got 6 for A, you can literally plug it in for A. Now, look at how much of a mess that is. That's not nice. So let's try it a different way. Let's work at it like we actually know what we're doing with algebra. So prepare for some exciting algebra. Now, algebra, when we say the word algebra, basically what you need to think about is a teeter-totter. Okay? So we've got a teeter-totter. We've got it like this. Whatever we have on one side, if it's a box of whatever size, we need to have the same size box on the other side for it to be horizontal. If I take off this box all of a sudden, what happens? Well, our teeter-totter is no longer even, so our teeter-totter will go down like this, and it's uneven. Okay? So an equal sign, if there's an equal sign, our sides of our teeter-totter have to have the same amount of things in order to be equal. Okay? So if I take off one thing on one side, like let's say I take off that top box, I have to do it to the other side to be equal. Or if I add a box, I have to add a box to the other side to be equal. Okay? So that's our first thing. Think about the equal sign as a teeter-totter. So let's write out our equation again. 6x equals plus 2y equals 4. What I want to do is I want to get it into this y equals mx plus b form. So I want to get y by itself first of all. Okay? So to do that, I'm going to use a different color here. Let's choose red. I want a minus 6x on this side because I don't want the 6x on that side. If I do it to that side, just like our teeter-totter, I have to minus 6x on this side. So if I do that, I get 2y equals 4 minus 6x. Now, hopefully you see that 6x and minus 6x cancel, and that's why it works. Okay, now we still need to get the y by itself to have this y equals mx plus b form, so we're still working at it. The way to do that is to divide, right now it's being multiplied by 2, so we have to divide by 2. If we do it to one side, we have to do it to the whole other side. Don't forget that has to be to both the m and the b. Okay, so then we have, let's choose green again, y equals 4 divided by 2 minus 6 divided by 2x. Okay, so pretty good, but still not quite in the form y equals mx plus b, so I'm just going to move stuff around so it looks better. And hopefully you realize that 2 divided by 2 is 1 over 1, which is just 1, so it's like we canceled it. Okay, I'm just moving stuff around so that it's in this y equals mx plus b, and actually let's do some simplifying of our fractions here. Oh, even more simple. Maybe we don't want that number. Whatever. Okay, so negative 3 x plus 2. Okay, now we could see fractional numbers, and if we do, I'll talk about it in a second. Okay, so that's what we've got as our y equals mx plus b. Now, our step 2 is use b as the first point on the graph, or the y-intercept. So b is this 2 here. 2. Okay, so I'm going to look on my graph here and put down where y equals 2. That's my point. Okay, then I need to find the slope, which is the m, -3. From right here, -3. Okay, so what that means is my slope would be, equals -3 over 1 equals rise over run. This is a really important concept. So, using my amazing graph here, I have to go down 3, so 1, 2, 3, and then to the right 1. So that would be my point. Okay, I'm going to do it again, except the other direction, so up 3, so 1, 2, 3, and to the left 1. And so if you follow this along, this should be my graph. Let's see if I can draw it here. That's pretty close. There you go. So we've got ourselves a line, and I like to draw arrows on the end. I think that it makes it much more clear that it goes on to infinity. So there you go. That is how you do linear equations from a different form into a graph. Now you can try your own. This one's going to be slightly different. It's got a fraction. So pause the video here and try this. Okay, you should have, for y equals mx plus b, you should have y equals 1 over 3 x plus, actually negative 1 over 3x plus whoops, I made a mistake. Negative 2 over 3 x plus 2. Yes, there you go. So that's what you should have. So your y-intercept then is the 2 from that, and your slope is negative 2 over 3. So if you were to draw it on the graph, I would go to 2, negative 2 as a rise, go down by 2, and then to the right by 1. Or by 3, sorry. Because our bottom here is 3, so rise over run. It's important. Okay, down by 2, run of 3. Okay, so I've done a couple spots. Now I'm going to use my ruler. That's pretty close. Alright, so hopefully you had a graph that looked like this. And that is how you graph other forms of linear equations. Good luck.